Hey guys, welcome back to another episode of Cracking the Coding Interview, the #1 book for all software engineers or software engineering interviews in general. Today we're going to be solving a problem called one-away. Keep in mind this is a problem we solved before in the past, and we solved it using what we call a dynamic programming method called the Levenshtein distance, but today we're going to solve it in a much simpler method because this happens to be an O of n squared time algorithm. Today we're going to solve it in an O of n, just a simple O of n. So feel free to pause the video to read through what the problem is asking for, but I find the examples more descriptive. So given two words, word 1 and word 2, we want to return true if they're only one distance away from each other. For example, to get from word 1 to word 2 in this example, all you have to do is delete A, right? And we're allowed to do 3 moves: insert a character, remove a character, or replace a character. Those are the only 3 moves allowed. So again, given this word, to go to this word, all we have to do is delete S, which is just remove a character, 1 move. From here to here, all we have to do is replace P with a B, okay, which is also replacing a character. It's 1 move. Now to finally to get from here to here, we have to do 2 moves: replace P with a B and replace L with a K. So since it's 2 moves, they're obviously not 1 or 0 edits away, so we have to return false. So let's get our hands dirty and code. Again, this is the previous O of n squared algorithm. Now we want to solve it in O of n. So first, I'm gonna say pass for this guy. Okay. Now I'm gonna go ahead and create 2 scenarios. The first scenario, the function I'm gonna call one away equal length. This is a scenario that's gonna take care of a situation where word 1 and word 2 have exactly equal lengths. Okay, so for now let's say pass. Let's go back to the example. In this example, for instance, in this case, right, they have equal lengths. However, in these two cases, they have equal lengths, right? So that function will take care of it. But however, in these 2 examples, example 1 and 2, they are different lengths. So we have to take care of a case for that too. So I'm gonna create a second function, def, okay, and call it one away different lengths, just diff length. Okay, this is for the case where we have 2 words with different lengths. Okay, so now for now let's say pass. Let's go ahead and edit our sim length first. So the sim length is pretty simple. We're gonna assume that we're always gonna be given lowercase letters, so we don't have to check for it. Or actually, let me go ahead and check for it here. So I'm just gonna see word 1, word 2 equals. I'm just gonna go ahead and convert them to lowercase here. Okay, so far so good. Okay, let's go ahead and run this just to make sure everything's okay. We should return none once we do this. Good, none, just like we said. So the first case of equal lengths, what do we want to do? Let's initialize a variable called count to 0. This is going to keep track of the number of edits we have to do. And I'm going to iterate for I in range length. Again, now it doesn't matter if we use word 1 or word 2 in this case because we've established their equal lengths. So I'm just going to say word 1. Okay, so iterating through each of the indices of word 1. If word 1 of I is not equal to word 2 of I, in the case they're not equal, obviously we would have to make an edit in that case. So we're going to increment our count. It doesn't matter what edit we have to make, but in the case they're not equal, we have to make 1. And if we increment count and count happens to go greater than 1, just go ahead and return false. Okay, because the problem is called one edit. However, we complete this for loop and we never return false, true. We just return true. This means for a case where they have the same length, word 1 and word 2, this is simply what we do. Okay, so now let's edit the second guy where they don't have the same length. In this case, we're going to use pointers to solve it. So I'm going to initialize a variable called I. I'm going to set him equal to count. So I'm initializing 2 variables, I and count, and they're both going to be equal to 0. Okay, initializing I and count at 0. So I'm going to say while I is less than the length of word 2. In this case, I'm assuming, keep in mind, I'm assuming word 2 is the smaller guy, not the larger guy. Word 2 is the smaller guy. Okay, while I is less than the length of word 2, what I want to say if word 1, keep in mind we're assuming word 2 is the shorter, has the shorter number of characters, I plus count. Okay, keep in mind in the first case I and count is 0 0, so in the case where he's equal word 2 of just I, we're just gonna increment I. However, if these two words are not equal, okay, which is the else case, okay, these two characters are not equal, what do we want to do? Okay, we want to increment our count, saying, okay, hey, we have to make an edit here because it's not equal. And if count ever gets greater than 1, just go ahead and return false. Okay. However, if we go through this while loop completely and we never return false, just go ahead and return. Okay, so now we've taken care of the case. Let's assume this works for now. We've taken care of the case where word 1 and word 2 are different lengths. So now in our main code, here's where we actually go to work and do. So I'm going to say if the absolute value, okay, of the length of word 1, okay, you know what, let me change here and use S1 and S2 just because I can. To be honest, it doesn't matter what you do, so I'm just going to change it to S1 and S2. Okay, of length of S1, okay, minus length of S2. If this absolute value happens to be greater than 1, okay, meaning it's 2 or 3 or 4, okay, what do we mean by that? If this absolute value happens to be greater than 1, this simply means that it has to be more than one edit, right? Because we're going to have to change more than one thing to get it to match. So we just simply return false. Okay, however, now this is our first case, so let's do elif. Okay, so now if there's less than 2 differences, okay, meaning there's at least one edit, right? Let's go ahead and check. So in the case where these guys are equal, where their length is equal, well, if they have equal length, okay, obviously that's the first case. This case, equal length check. So what do we do in this case? All we simply do is call that function, return equal length. Don't forget we're using S1 and S2 in the scope of this function. So now let's check one more. elif say string 1 happens to be longer, okay, string 1 happens to be the guy that's has greater length. Keep in mind in this implementation, different lengths, we assumed word 2 was the guy who's shorter. So in this case, string 1 is longer, meaning word 2 is shorter. So we're just gonna return a call to this function just the way he is. Okay, don't forget S1, S2. Okay, now the last elif check. Elif now is the case of the reverse of this guy. String 2 happens to be the longer guy. Okay, again, it's the same. We're going to call this. However, since we assumed in the scope of this function that the second element we're passing in is the shorter length, and this algorithm is dependent on this guy being the shorter guy, we're going to call this function, however, passing S2 in place of S1 and S1 in place of S2 because S1 is the shorter guy. So let's go ahead and run this and see what we get. Okay, we get true, right, because S, and so all we have to do is delete S. Let's try the false case in this example, which is pale and bake. So the first one is pale, go ahead and delete the S. Second one is bake. Let's make it uppercase just cause. So we should, oh, we're getting it true, so we're gonna have to figure out what's going on. Okay guys, so I figured out what was going on wrong. The problem is right here we're forcing S2 to equal to S1 lower. So we have to change it to S2. So now we should get a false. Okay, good. Now we get a false. Now let's try back what it was. Let's try P-A-L-E, P-A-L-E-S. Okay, that should be true. Good. Okay, so that's it for the video, guys. I hope this was helpful in showing you guys how to handle this. Although this looks like a lot of code, each of the sections of this code is very simple and easy to understand. That's it for the video. I'll see you in the next one.